Hey everyone, and welcome back for another deep dive. Today we are looking at some really cool ways technology is being used in education,
Oh, yeah.
specifically for teaching gravitation,
Yeah.
which we all know can be a pretty tough concept to grasp sometimes.
It can be really abstract for sure.
Absolutely, and it seems like some teachers over in Singapore have figured out a way to make it click using computer simulations.
Interesting.
So let's dive into our source material, which is a blog post about the 4th Junior College Physics Instructional Programme Support Group sharing, or IPSG.
Yep.
This took place in Singapore on January 18th, 2012, and it was basically a big gathering for physics teachers to network, share resources, and just talk shop.
Oh, wow. That's awesome.
Yeah, it sounds like a fantastic event, and over 200 teachers attended.
Wow, that's a big turnout.
Yeah, so it seems like there's a really vibrant community of physics educators over there.
That's really cool to see.
Yeah, so one presentation that really stood out to us was titled Promoting Independent Learning in the Topic of Gravitation Using Easy Java Simulations. And this was given by Jimmy Go, Jim Witan Haukai, and Wei Lu Kang from Yushin Junior College, along with some folks from the Educational Technology Division.
So they're really like bringing together the teaching expertise and the technology side of things.
Exactly. And I think that's a really important point because, you need both of those elements to make this kind of innovative approach work.
Absolutely.
But before we get into the specifics of the simulations, can we just take a step back and acknowledge, why is gravitation so difficult to teach in a traditional classroom setting?
Yeah. I mean, you can't see gravitational fields, right? Like you can't see the forces acting between objects.
Right. It's not like we can just pull out a planet and demonstrate it in the classroom.
Exactly. And even demonstrating gravitational effects on small masses, like in a typical school lab, that can be really tricky too.
Yeah, it's a challenge to make it really tangible for students.
For sure.
So what did these teachers come up with? Well, they took these easy Java simulations, which are basically like interactive physics sandboxes.
Right. Yeah.
And they modified them to specifically address the challenges of teaching gravitation.
Okay, so they're making it more visual, making it more interactive for the students?
Exactly. And they actually incorporated these simulations into their existing tutorial questions so the students would have a chance to kind of play around with these simulations before they even get to the classroom discussion.
Oh, that's a cool approach.
Yeah, it encourages that independent learning and it gets them thinking critically about the concepts before they're even presented in a formal setting.
That's a really great way to make students more active participants in their own learning rather than just, passive recipients of information.
I agree. And the fact that they had the Educational Technology Division involved shows a real commitment to innovation and collaboration, which is awesome.
Yeah, it's great to see that kind of support.
Okay, so they actually ran a pilot study with a JC1 class back in July 2011, and the student feedback was really positive.
Interesting.
Yeah, they did mention that the assessment grades didn't show a significant improvement. But, even if the grades don't immediately reflect it, I think positive learning experiences like that can have a long-term impact on how students feel about a subject.
I think so too.
And that can really spark their interest and make them want to learn more.
Absolutely.
So one of the simulations they used was called the EJS Open Source Gravitational Field and Potential of Earth and Moon Java Applet.
Okay, so what can students actually see and do with this simulation?
Well, you can actually see the gravitational field between the Earth and the Moon.
Wow.
And you can manipulate the variables, like you can change the masses of the celestial bodies and observe how objects would behave under different gravitational conditions.
Oh, that's amazing.
Yeah, it's like having a mini universe at your fingertips.
I can see how that would make things a lot more understandable than just, looking at a static diagram in a textbook.
Right, and think about the possibilities. You could have students launching virtual satellites.
Oh, cool.
And then they can actually see how those satellites would orbit based on the gravitational forces involved.
Yeah, that would be a fantastic way to get them to really understand those concepts of, like gravitational fields, potential energy, and even orbital mechanics.
Exactly, and it just makes it all so much more visual and engaging.
Totally.
Now, there is one little detail in the source that I found interesting. It mentions that they had some challenges due to the lack of Java 3D on the AJC school laptops. So it's a good reminder that even with all the best technology and intention, sometimes you run into these real-world obstacles.
Yeah, for sure.
And it takes some resourcefulness and adaptability to overcome them.
Absolutely.
But that's part of what makes it so impressive when educators can pull it off.
Totally, I agree.
Okay, so one more thing I wanted to mention. The source also lists a presentation titled Learning Gravitation by Inquiry using easyjavasimulation.ppt.
Okay.
And we don't have access to the content of the presentation, but just the title alone sparks my curiosity.
Yeah, mine too.
Like, what kind of inquiry-based activities were they using? How did they actually leverage those simulations to guide student learning?
Yeah, it sounds like a treasure trove of ideas just waiting to be uncovered.
Exactly. And it makes you realize, like, how much potential there is for using technology in really creative and innovative ways to teach these challenging concepts.
Yeah, I'm really intrigued to see what else they were doing with these simulations.
And I think that's a great segue to our next topic, which is another presentation from this IPSG event that focused on a totally different approach to teaching physics.
Oh, wow.
So let's jump into that after a quick break.
Sounds good. Yeah, it's like a treasure trove of ideas just waiting to be uncovered.
Exactly. And it makes you realize, like, how much potential there is for using technology in really creative and innovative ways to teach these challenging concepts.
Yeah, I'm really intrigued to see what else they were doing with these simulations.
Right. And, speaking of hands-on learning, there was another presentation at this IPSG event that caught my eye.
Oh, really?
Yeah, this one involved students actually building their own projectile launchers.
Wow, that sounds like fun.
Yeah, this presentation was titled Student Projectile Launcher Project, and it was given by Pek Penkia and Lim Li Chen from NUS High School of Math and Science.
Okay.
And they had their students work in teams to design and build these devices that could launch a golf ball over a barrier and into a target area.
So they're really putting those physics principles to the test.
Oh, absolutely. They had to factor in everything from kinematics and forces to energy and even a touch of aerodynamics to make those golf balls soar just right.
I bet the students love that.
I can only imagine the excitement in that classroom.
Yeah, it's like taking those textbook concepts and bringing them to life.
Exactly. It's no longer just about memorizing formulas. It's about understanding how those formulas translate into real-world outcomes.
I bet there was a lot of problem solving involved, too.
Oh, for sure. They had to tinker with their designs, make adjustments, learn from their mistakes.
Right, like figuring out why their launcher didn't quite hit the target and what they could change to improve it.
And those aha moments when a design finally clicks, those are invaluable.
Totally. And let's not forget the teamwork aspect.
Right. Working collaboratively on a project like this teaches them how to communicate, effectively delegate tasks, learn from each other's strengths.
Those are skills that will serve them well no matter what field they go into.
Absolutely. It's not just about the physics. It's about developing those essential life skills.
It really highlights the power of project-based learning, doesn't it?
It does, and it makes you wonder if there are ways to adapt this kind of approach to other subjects beyond physics.
Oh, yeah. Like, could history students build models of ancient cities?
Right, or recreate historical events through interactive simulations.
Ooh, that'd be cool.
And what about language arts students? Could they create digital storytelling platforms?
Or design their own interactive narratives.
The possibilities are endless.
It's really exciting to think about how we can take these innovative teaching methods and apply them across disciplines.
But before we get too carried away with hypotheticals, let's dive into one more presentation from this IPSG event. This one caught my eye because it involves something we all have in our pockets these days, our phones.
Oh, intriguing. What do they do with those?
Well, this seminar was titled Video-Based Physics Teaching Using Authentic Real-World Scenarios to Engage Students. And it was presented by Samuel Oi Junwei from National Junior College.
Okay.
And his focus was on using video analysis to make physics more relatable and engaging for students.
That's clever. Video is such a ubiquitous part of our lives now. It makes sense to harness its power for educational purposes.
Exactly. So imagine this. You're in a physics classroom and a student launches a ball in projectile motion.
Look.
Instead of just observing it with the naked eye, you film it with a phone camera.
Okay, I'm following.
And then using free motion tracking software, you can superimpose velocity acceleration and force vectors right onto the video.
Wait, so the students can actually see those abstract concepts playing out in real time?
Exactly. Suddenly those equations and diagrams in the textbook aren't just abstract symbols.
Right.
They have a direct visual connection to a real-world event that they just witnessed firsthand.
That's brilliant. It's like bridging the gap between theory and reality.
Right. And the best part is it's not limited to classroom experiments.
Oh.
Junwei suggested using videos from YouTube as well.
Interesting.
Imagine the possibilities analyzing the motion of a skateboarder,
Yeah.
a basketball player, even a rocket launch.
Wow. It's a fantastic way to tap into students' interests and show them that physics is everywhere.
It really expands the definition of what a physics lab can be.
Absolutely. And it makes me wonder.
Like, are we just scratching the surface of video's potential as a learning tool?
Yeah, I think you're right.
Maybe in the future, video analysis will be as common in the classroom as textbooks and whiteboards are now.
It's definitely possible. I mean, think about it. It's accessible, it's engaging, and it's incredibly versatile.
Exactly, and it can be adapted to suit different learning styles.
Right, like visual learners, kinesthetic learners, students who learn best through hands-on experiences. Video analysis can really open up a whole new world of understanding for them.
It's like giving them the tools to explore their own curiosities at their own pace.
And it empowers them to become active creators of knowledge rather than passive consumers.
Right, they can film their own experiments, analyze real-world phenomena, even create their own educational videos to share with others.
It's a real shift from that traditional teacher-centric model to a more student-driven approach.
I love that idea, and it makes me think about all the different ways we can empower students to take ownership of their learning.
Yeah, it's really exciting.
But okay, let's zoom out for a second and think about what we've uncovered in this deep dive.
Okay.
We started with your curiosity about how technology is changing the educational landscape.
Right.
And we've seen how a group of dedicated physics teachers in Singapore are using everything from interactive simulations to student-built projectile launchers to video analysis.
Yeah, it's amazing to see what they're doing.
And it's not just about the technology itself. It's about that mindset, the willingness to embrace new approaches and tailor them to meet the needs of diverse learners.
It's really inspiring to see their passion and commitment.
It is. So as we wrap up this deep dive, what's the one thing you'll take away from our exploration of these innovative teaching methods?
I think for me, it's the realization that education doesn't have to be confined to textbooks and lectures.
Right.
There's a whole world of exciting possibilities out there, and technology can be a powerful catalyst for creativity, exploration, and deeper understanding.
I couldn't agree more. And it's a reminder that learning can be an adventure. And with a little ingenuity and a willingness to embrace new tools and approaches, we can really unlock the potential for every student to thrive.
Absolutely.
So what are you going to explore next? Will you dive into the world of open source physics simulations, maybe experiment with video analysis in your own backyard, or perhaps even build a projectile launcher with your kids?
The possibilities are endless.
On that note, we'll leave you to your own explorations. Until next time, happy learning.